Greetings. This is a short video looking at the equation of a line using the gradient and a point. So let's consider a Cartesian plane. And a ray, and I'm going to call that a ray with a gradient of m and a x coordinate x1 and a y coordinate y1, and we use the gradient formula y minus y1 over x minus x1, and we multiply both sides by x minus x1 times x minus x1, and these cancel to get our gradient intercept formula. Let's call out point A with coordinates x1, y1. And a very common misconception is that these need to be substituted, whereas they form part of y equals mx plus c, where c is the y-intercept. Just going to abbreviate that, y-intercept, and m is the gradient. And let's look at an example. Let's get rid of that. So let's write down our formula again. And this time we are given a gradient of -4. So m is equal to -4. And we've got a point, let's call that A, -2 and 3. And we can see that x1 here is -2 and y1 is 3. So we just substitute these values into our gradient intercept formula, which is here. Okay, so let's do that. So we've got m is -4, and we've got x1, which is -2, and we've got y1, which is 3. It's really important to use our parentheses here. A negative multiplied by a negative is a positive, and we just use the distributive property to distribute the -4 into this bracket. Let's do that then. -4x, -8 is equal to, we add 3 to both sides to get -4x, -5. So let's try another question. Okay, so this time we need to find the gradient. We're not given the gradient, so we use the formula y2 minus y1, x2 minus x1. So we can read off x1, y1, x2, y2. So here we get x1 is 1, y1 is 3, x2 is 4, and y2 is 8. So the next line we just insert parentheses. y2 is 8, y1 is 3, x2 is 4, and x1 rather is 1. So we work that out, we get 5 over 3. So that's our m value. We choose one point. You can choose this or that. I'm choosing A because they are smaller numbers. So we substitute that into our gradient intercept formula. So let's do that then. I'm going to do that in green. So we've got 5 over 3. We've got x minus 1. And then we've got y subtract 3. So let's distribute this into the bracket. We get 5x over 3 minus 5 over 3. I'm going to write this as a fraction out of 3. That's just out of 1 there. So that is 9 out of 3. So if we add 9 over 3 to both sides, we get y equals 5x over 3 plus 4 over 3. And I hope you can see this implies that the gradient is 5 over 3, which is what we got here, and the y-intercept is 4 over 3. And there's a model solution down below, which corresponds to our solution above. Okay, so this box here illustrates explicitly everything that you need to do. So it might be pertinent to copy that down. And here's 2 more examples. Now here we can use the concept of a gradient where m is the change in y over the change in x. So you might be more familiar with the rise over run. So here we can see that the change in x, or the rise, the run rather, change in x is 1, the change in y is 2. So this gives a gradient of 2 over 1, which is just 2. The next thing we do is we choose any point on the line. So it's pertinent to choose a point which gives integer values on a vertex of the unit grid. So I've chosen the point 2, 1. So we just substitute that then into our gradient intercept formula. X minus x1, y minus y1. So we've got a gradient of 2. We've got a x1 value of 2 and a y1 value of 1. So we can distribute this in, and I'm adding 1 to both sides, we get 2x negative 3, and we can see there that the y-intercept is negative 3 and a gradient of 2. So that means we go out 1, we run 2 and rise, we run 1 and we rise 2. Pause the video and see if you can do B. So let's consider the gradient. Gradient is the change in y. We can see that the change in y is 2. the change in x is also 2, but this is going in the opposite direction, so we need to give this a negative sign. So we get a gradient of -1. We choose one point. I'm going to choose this. Let's call that point A, and that has a coordinate of 2, 0. We then substitute that in to our gradient intercept formula. So we've got a gradient of -2. So we just distribute that in, -2x. Gradient is -1, not -2. So we get a gradient of, if we distribute that into the bracket, we get a gradient of -x, +2. So that corresponds to a y-intercept of +2 and a gradient of -1. Okay, so let's look at some other examples. Okay, so there's two graphs there, and the answers are below. I've done the worked solutions above. Okay, so I've got some graphs there, so pause the video and see if you can find the equation of each line. Okay, so hopefully you've done that now. So we've got an intercept there, so let's call this A and call that B. So the coordinates of A are 0, 2, and the coordinates of B are 4, 4. We've got the origin there, let's call that C and D. The coordinates of C are 0, 0, and the coordinates of D are 3, 3. Let's call that E and F. We've got a coordinate E, which is 0, 5, and we've got coordinate F of -8, 9. So let's find the gradient then. The gradient is the change in y values and the change in x. And let's label these thus x1, y1, x2, y2. So y2 is 4, subtract 2, and we've got x2 4, subtract 0. 2 over 4, so we get a gradient of half. We then substitute that in to our gradient intercept formula. So let's do that up here. So we can choose one of these coordinates. I'm going to choose x1 is 0 and y2 is 2. And we have a gradient of half. So let's write down our gradient intercept formula. Gradient of half, subtract x1, which is 0, y minus y1, which is 2. Let's distribute that into the bracket then. So we get half x, and half times 0 is just 0. So we get a straight line formula of half x plus 2. And we can see that that intercepts at 2. And we've got a gradient of half. Let's have a go to B. Let's work out the gradient first. We've got y2 minus y1 of x2 minus x1. Hopefully we can see without writing them down that y2 is 3 minus 0, and and we've got 3 again minus 0, so we've got a gradient of 1. And it seems pertinent to use x1, y1. So write down our gradient intercept formula. So we've got a gradient of 1, x minus 0, y minus 0. So I'm distributing there, we get x, 1 times 0 is 0, y, so we just get y is equal to x. C, let's work out the gradient. We've got y2 minus y1 over x2 minus x1. We've got a y2 value of 9 minus 5, and we've got a negative 8 minus 0. That gives 4 over negative 8, which gives a gradient of negative half. I'm going to choose E. Let's write down our gradient intercept formula. Gradient of half, our x1 value is 0, our y1 value is 5. Let's distribute that then, so we get negative half x. We add 5 to both sides. Let's rewrite that. And we can see it cuts at 5 and has a gradient of negative half. Okay, so don't need that. So have a go at doing these questions and pause the video and get rid of this. Okay, so hopefully you've done that now. We've got the answers here, and I'm going to choose probably the most difficult one, which is F. And let's find the gradient. We've got negatives, so I recommend putting in parentheses. And we've got, this is our x1 value, our y1 value, this is our x2 value, and this is the x3 value. And let's insert those. So we need a y2, x3. Okay, so we've got 4, negative 2, and we've got 3, negative 1. Okay, so that is 4 plus 2 over 3 plus 1. That gives 6 over 4. That simplifies to 3 over 2. So let's choose x1 to be 3 and y1 to be 4. We can choose any one, it doesn't matter. And it might be worth trying both of these to show that you get the same answer. So let's write down our gradient intercept formula. So we've got a gradient of 3 over 2, x minus 3, and y minus 4. Let's distribute this then. We've got 3x over 2 minus 9 over 2, and let's write this as a fraction out of 2. If we take this to the other side, we get negative a half, which is what we have here. So hopefully you had those correct. You've got the answers there to mark your work. Good luck with your revision.